Assalamu alaikum. So in this video we will find the integration of root over 10x, so it will be very long video. So let's start. So first of all we have to choose 10x, let's say it's equal to z square, and now if I take the differential of the both term, I will have at the left hand side sec square x dx, and here I will have 2z dz, and then if I decompose this sec square into 1 plus 10 square x dx, and let's write the right hand side again. Now what is 10 square x? As 10x is equal to z square, so 10 square x is simply is equal to z to the power 4, and we have dx 2z dz. Now let's write this dx alone at the left hand side, and we have 2z dz, then z to the power 4 plus 1 at the right hand side. Now why I have found this dx? Because I have to put this dx here, so let's put this here. So we have 2z dz, then z to the power 4 plus 1, and what is this root over 10x? As 10x is equal to z square, so root over 10x is equal to z, and I think you understand why I have chose 10x is equal to z square. Okay, so now I have let's write this to our sides, z square, then z to the power 4 plus 1, then dz. Okay, so now I have to apply one formula to find the denominator. So the formula is z to the power 4 plus a to the power 4, and the formula is z square minus root over 2az plus a square into z square plus root over 2az plus a square. Well, now I have to put this value here, and let's see what happens. So this is z square, then dz. We simply can write 1 is equal to 1 to the power 4. That means this a is simply is equal to 1, right? Well, so I have to put this value a is equal to 1, so z square minus root over 2, a is equal to 1, so I have to write here z, then 1 square is 1, then z square plus root over 2, a is equal to 1, z plus 1 square, that means 1. Well, now this is a rational function, and I have to decompose this into two terms. I will write this as the sum of two terms. At the first term's denominator will be z square minus root over 2z plus 1, and here I have to write the second denominator. Well, and let's write here dz. Well, now you can find the numerator. Now you have to find the numerator, and you have various ways to find the numerator. You may probably thinking that we will write az plus b, then cz plus d, and then we will find in the in which technique we will find a, b, c, d. But we can find the numerator with using some common sense instead of this method. So let's use some common sense. Okay, so let's analyze the numerator. Let's only analyze the numerator of this. Okay, and don't forget that we have a z square here, so the numerator of this and the numerator of this must be equal to z square. Well, so let's start. So if I place here 1 and place here let's write here minus, so what will happen? This term will be multiplied with this, so I will get z square this thing, and then we have to minus this thing, so z square minus root over 2z plus 1, and if you find the summation of if you find this, you will get 2 root over 2z. Well, so we have a z to the power 1 here, but you see you have a z square here, so that means 1 is not a wise we can choose 1, so we can choose this. So let's omit this thing, let's omit this one here, and let's choose some another thing. Let's choose here z, and let's choose here z. Okay, so let's now find what is the numerator. So first I have to multiply these two things, and I will get z into z square plus root over 2z plus 1, and then I have to multiply these two things. Don't forget I have a minus here, so minus z square minus root over 2z plus 1. Well, now I have to find z cube plus root over 2z plus z, then minus z cube plus root over 2z square minus z. Well, so these two cancels out, these two cancels out, and I have 2 root over 2 z square. So you see I have a z square here, and I also have a z square here. Don't worry with this extra 2 root over 2, because we can now compensate this. Okay, so now let's see what happens here. That means the numerator of this is simply is equal to 2 root over 2 z square, but we have a z square here, so that means we have to compensate it. We have to compensate this extra 2 root over 2, and to do this we just need to divide by 2 root over 2. Okay, so now let's proceed. So now you see we was here, that means what we get here, this is simply is equal to root over 10x dx, and root over 10x dx is equal to this. And now we will solve this integration. First we will solve this term, and let's assume that this term is equal to I1, and then we will separately solve this term, and let's assume that this term is equal to I2. Well, so first let's find what is I1. So I1 is equal to z, then z square minus root over 2z plus 1, then integration dz. Well, now let's see what is I1. So first of all, let's choose this denominator. Let's choose this denominator is equal to f, and f is equal to z square minus root over 2z plus 1. So what will be if I differentiate df by dz, then I will get 2z minus root over 2. So you might be wondering why I am doing this. You will understand it later. First just see there, now I have to make this 2z minus root over 2 here. Okay, so let's try to make this thing. Well, so let's write here z square minus root over 2z plus 1, and you see that here I have z, but I have here 2z, and I have to make this here. So let's make it. I just have to write here 2z, but you see, is there any 2 here? No 2 here. That means I have to compensate this 2, and to do this I have to write here 2. Well, now let's proceed. You see I have a minus root over 2 here, so let's write here minus root over 2. But you see any minus root over 2 here? No. So to compensate it, you have to plus root over 2. Okay, so now let's take this thing and then take this thing. So we will now divide this thing with the denominator, and we will get 2z minus root over 2 2z square minus root over 2z plus 1. Okay, dz, and then we will divide this by the denominator, and we will get root over 2, then 2z square minus root over 2z plus 1 dz. Okay, so let's now work with the first term. You see here that df by dz is equal to 2z minus root over 2. So df is simply is equal to 2z minus root over 2 dz. Well, now why I have written this? Because I can put this value here. So let's put this value here, and we will get a df here. Okay, so now let's put this f here, and I will get a f here, right? Well, now let's take this 2 outside, 1 by 2, and what is the integration of this thing? This is simply is equal to ln modulus f, right? And what is f? Let's put the value of f here. Let's put the value of f here, and we will get z square z square, then minus root over 2z, then plus 1. Well, so I have successfully find the integration of the first term. Now let's work with the second term. So these are the coefficients. Let's write it outside. Now I have here z square minus 2 root over 2z plus 1. So let's write this thing here. So I have z square minus root over 2z plus 1. Now listen to me carefully. Let me write here z square, then I will write here 2. Don't question me why, just look, 2z. You see here I have root over 2z, but here I have 2, so to compensate it I have to divide by root over 2, and you see this term and this term is now equal, and then I will write 1 by root over 2 square. And you see, is there any 1 by root over 2 square here? No. So we have to compensate this, and to compensate it we have to minus it, and then I will write this 1 here. Now why I have did this, why I have done this? Because this thing is none but a minus b whole square formula, right? So this is equal to z minus 1 by root over 2 square. So please watch the video again, watch this part again, and you will understand it. And let's write this thing is equal to minus half plus 1, so this is equal to half, right? And half can be written again as 1 by root over 2 square. And so let's put this value here, and I will get here dz, and at the denominator I have z minus 1 by root over 2 square, and then 1 by root over 2 square. Okay, so now up to here I have to find formula. I have to use one formula, and the formula is integration of 1 by z minus alpha or plus alpha, whatever you want. Let's say it's minus alpha, so minus alpha square plus a square dz is equal to simply 1 by a tan inverse z minus alpha divided by a. Okay, so let's use this formula here and let's see what happens. So I will write here, so I will write here, first of all I will write here 1 by a, so this is actually a and this is actually z minus alpha. So first let's write 1 by a, then tan inverse z minus alpha, actually alpha is equal to 1 by root over 2, then 1 by root over 2. Okay, so now I have to simplify this thing, so this thing will be equal to 1, right? So let's write here 1, then tan inverse, if you simplify this term, just multiply root over 2 with the numerator and denominator, and you will get root over 2z minus 1. And here I have half ln z square minus root over 2z plus 1. You see, I use a modulus here, but no modulus inside tan inverse. And you can write here c a constant, but that's not a big deal. Okay, actually it's a big deal, but we will use it later. Okay, so I have successfully find I1, and now I am going to find I2. Okay, and I have a minus here. Okay, no problem, just let's find this I2, avoid this minus, just find this I2. So what is I2? I2 is integration of z, then z square plus root over 2z plus 1, then dz. Let me say this again, z square root over 2z plus 1, z square plus root over 2z, z square plus root over 2z plus 1. Okay, so now I have to find this. Again I will choose this denominator f, f is equal to z square. Well, let me choose this g, another denominator. So g is equal to z square plus root over 2z plus 1, and again I will differentiate g and I will get 2z plus root over 2, and again I have to make this here at the numerator. So let's do this again. So let me write z square plus root over 2z plus 1 again here, and what I have told you, first I have to make here 2z. So let me write here 2z, but you see here I have z extra 2 here, so to compensate it I will write here 2 like previously, and then you see I have extra root over 2 here, so I have to write here root over 2. But do you see any root over 2 here? No. So I have to, so to compensate it I will write here minus root over 2. Well, now I will take this, I will divide this thing with the numerator, and I will get 2z plus root over 2, 2z square plus root over 2z plus 1 dz, and then I will divide this root over 2 with the denominator, and I will get 2z square plus root over 2z plus 1. Well, so now I will work with the first term. It's easy, right? You see that, oh, there's some noise here. Okay, so now I will use this g here, then I will get 2 into g. Let's write this 2 outside. Let's write this 2 outside. And what is this? This is simply is equal to, let's see, if I write the I can write this line dg is equal to 2z plus root over 2 dz. So let me write it here, and I will get here dg. And what is the integration of dg by g? This is simply is equal to ln g, and let's write the value of g, and I will get what? I will get z square plus root over 2z plus 1. Okay, so now I have to find the integration of the second term. So first of all, let's put this coefficient outside, and I will get root over 2 by 2. Okay, so now let's work with the denominator. Let's see what will be the denominator now. Z square plus root over 2z plus 1. Now let's see. Again I will try to make some a plus b whole square or a minus b whole square here. So now let's write z square, and as the formula a square plus 2a plus b square, I have to write here 2. Then I will write this z here, and you see I have root over 2, and but I have write here 2. So to make this term root over 2z, I have to write 1 by root over 2, and then I will write here 1 by root over 2 square. You see any 1 by root over 2 square here? No. So now to compensate it, I will minus this term, and then I will write 1. And you can see again that this term is equal to a plus b whole square. So z plus 1 by root over 2 whole square, and this term is simply is equal to half, and half means this. Okay, so let me put this value here, and let's see what happens. So z plus 1 by root over 2 square plus 1 by root over 2 square. Okay, so now let's write this thing, root over 2 divided by 2. I have to use the formula again, and the formula is dz. Again I have said I can write here z plus alpha or z minus alpha, both the equation will be correct. Then I will write here a square, and the formula is 1 by a tan inverse z plus alpha divided by a. So I will choose this thing is z plus alpha, and this thing is simply a. So let me write the formula here. So first I will write 1 by a, and then tan inverse z plus alpha, then divided by a. Well, now again this term is equal to 1, and I have again tan inverse root over 2 z plus 1. Well, so this is the value of I2. I think two answers are similar. I think I1 and I2 are similar here. Well, I have a plus tan inverse plus, and here I have a minus. Okay, no problem. So I have successfully found I1, I2 and I1, and now I have to place these values here to find the integration of root over tan x. So let's see. Let me copy this thing, and then again let me paste this thing, and now I need to place these values I1 and I2. So this is simply is equal to 1 by root over 2. Well, now I1 first, I1 is actually is equal to this, right? Let me copy this thing and paste it here. Well, so this is I1, I have a minus here, and then let me place the value of I2 here. So I will write the I2 here. So this is my I2. Let me copy this thing. Now let me paste this value here. Well, so this is the final answer, and then I can write the indefinite integral c. Well, now you can write this ln minus ln. You know the formula. You can also use this formula, tan square x plus tan square y. That means you can further simplify this thing, but I think you have understood the process. Okay, so thank you.